Okay, konting review lang, no? Let's try to review a little bit what we took up last week, no? Okay. So what is the difference between these two numbers? Okay. Can either of you tell me what the difference is between these two? No? Between this and this? Joseph or Albert? Joseph, what is the difference between the two?
Not sure po. Phasor po ba yung isa?
Yeah, no? So the difference is, this is just, this one is a complex number. This one is a phasor. Okay, so what is the difference between a complex number and a phasor? Joseph. Nakalimutan na.
Yes po.
Albert, may idea ka? What is the difference between a complex number and a phasor? Nakalimutan na rin. Are you with us, Albert?
Yes, sir.
Okay, the difference is, okay, yung complex number is just a point in your complex plane, no? Yeah, complex number is a point in the complex plane. No? So yung complex plane natin, if you will recall, I have my imaginary axis, I have my real axis, I have a complex number here, A. No? Yung real part nun is small letter A, and yung imaginary part nun is JB. Okay. Ano ngayon kung phasor? What about the phasor? What is the difference? Okay. A phasor is a rotating vector in the complex plane. So ito, this one is stationary. Pero pag phasor, nagbabago yung position niya. So ang phasor, okay, let's say this is A, okay, that is A, ito umiikot at an angular velocity of omega. No? So might think of it that way, no? Umiikot yan at an angular velocity of omega in the counterclockwise direction. Okay, so do you understand now the difference? Okay, so ito, sa complex plane, this is stationary. Ito, sa complex plane, umiikot ito. Okay. And ang ikot niyan is at an angular velocity of omega radians per second. Okay. Again, no, a lot of people, no, kahit ang mga triple E students, pag minsan they are confused, no? They don't know the distinction between just an ordinary complex number and a phasor. No? So to differentiate, linalagyan natin itong symbol sa taas or linalagyan natin ng ng argument yung phasor ace of j omega. J omega is your argument. The reason why we put this argument, first to indicate that it's a complex number, and second, that omega is actually a variable, no? It's a variable, although it's an implied variable. Okay, second, no? Phasor transformation. Okay, our Phasor transformation, if we have a sinusoid, f of m, okay, cosine omega t plus, let's say, alpha, okay, the Phasor transformation would be, okay, f of m at an angle alpha. F of m at an angle alpha, no? Where this is a Phasor. Sorry. I don't want to write it that way. No? So this is f of t, no? This is f of t is equal to f of m cosine omega t plus alpha. Okay. This is now going to be the Phasor f, no? Which is going to be f of m at an angle alpha. No? Where this is a Phasor, no? So alam nating Phasor siya because of the vector sign on top of the f. Okay? Actually, kung hihimayin natin to, no? What is this? This is composed of two components. This is composed of f of m, okay, cosine omega t plus alpha, okay, plus j f of m sine omega t plus alpha. No? Okay. And makikita na natin yan from the vector diagram, no, or the Phasor diagram. Kung ito umiikot at an angle omega t, okay, so initially this is alpha at t equal to 0, okay, this becomes omega t plus alpha at some time t, no, at some time t. And if you take a look at the real component of that, itong real component yan would be f of m cosine omega t plus alpha. Ito yun, no? This is the real component, and then this is the imaginary component. The imaginary component would be j f of m, where this is now f of m, sine omega t plus alpha. So actually, sa Phasor transformation, we are adding an imaginary component. No? So the Phasor transformation adds an imaginary component to f of t. Kasi ito yung original f of t natin, kino-convert ngayon natin to this. No? Where this is our original f of t, no? Ito yung original f of t natin. No? Pero dinadagdagan ngayon natin itong imaginary component. Okay. Ngayon, ang ginagamit natin in this course is yung modified Phasor transformation. Okay? Where ang ginagawa natin, f of t is equal to f of m cosine omega t plus alpha. Our transformation now is f, okay, is now f of m over the square root of 2 at an angle alpha. So we divide by the square root of 2. No? Divide by the square root of 2. Naalala nyo why we divide by the square root of 2, Joseph? Do you remember? Or Albert?
RMS po, root mean square.
Para, that's right, no? So that we are working with RMS values. Instead of working with amplitudes, we are working now with RMS values. That's why we divide by the square root of 2. And then the reverse transformation, if I have f is equal to Ito na lang, no? Let's say F is equal to F at an angle alpha. Sorry. Wala dapat nung... No? F is equal to the magnitude. This is now magnitude of F at an angle alpha. Then my reverse transformation is F of t will now be the square root of 2 times the magnitude of F cosine omega t plus alpha. So in the transformation, we divide by the square root of 2. In the reverse transformation, we multiply by the square root of 2. Okay. Okay, then we took up impedance, ano? So this is an element. This is an element or a circuit. Can be a circuit. Let's say I have a phasor I flowing and a phasor V across it. Okay, if I get the ratio of V over I, so these are both phasors, this is equal to Z. Z is not a phasor, no? And this is called impedance. And this is not a phasor. Yung V is a phasor, I is a phasor, but if you get the ratio of V over I, that is not a phasor. Okay, that is called impedance, Z. This is just a complex number, no? Just a complex number. Okay, so you might think of it this way, no? When we're dealing with DC, V over I is equal to R. When we're dealing with phasors, V over I is equal to Z. No? So DC, V over I is equal to R. No? When we're dealing with phasors, V over I is equal to Z, where Z is a complex number. Yung Z natin is a complex number. This will be of the form R plus JX, where this is the resistive component of Z. This is the resistive component. And then this is the reactive component. You call this now your reactance. X is called your reactance. Ngayon, yung ano naman, yung reciprocal, if you get I over V, that is called your admittance Y. Sorry, this is not a phasor. Pati ako nagkamali, no? That is not a phasor. That is called your admittance Y. Okay? So this is admittance. No? And Y will be of the form G plus JB, where this is your conductive component, or your, this is your conductance, and then this B, you call this your susceptance. Okay, for our passive elements R, so you have R, you have L, you have C. Okay. The impedance Z, okay, the impedance of R, no, is also equal to R. Tableton. This is a table. The admittance of R is equal to 1 over R, which is equal to G. The impedance of L is J omega L. The admittance of L is minus J over omega L. And the impedance of C is minus J over omega C. The admittance of C is J omega C. No? And we derived this last time. No? We spent some time deriving this last time. No? So when you naalala, you just go back to the recording of last lecture. Okay, so any questions? So this is just a review of what we took up last time. May mga tanong ba? Okay, that's why I was saying last week, masanay na kayo dealing with complex numbers, no? Kasi from this point on up to the end of the course, you're going to be dealing a lot with complex numbers because that's how we're going to be dealing with circuits with AC excitation. We're going to be dealing with circuits with AC excitation, not in the time domain, but in the phasor domain, or sometimes we call it the frequency domain. Okay, so we're going to jump into the phasor method of circuit analysis. So you also call this the frequency domain analysis. And what we do in the phasor method of circuit analysis is performed on transform networks. How do we transform the network? No? If we have a network, we transform it by transforming the AC quantities into phasors and transforming the passive elements into impedances. So dun sa network natin, kung AC ang excitation, all the AC quantities gagawin nating phasor, lahat ng passive elements gagawin nating impedances. Now you'll notice that the relationship between voltage and current for all circuit elements in the phasor domain is algebraic. Wala tayong integration, wala tayong differentiation, no? And that can be seen from here, no? Okay? That can be seen from here. The ratio of V over I for all these elements, the ratio of V over I is really just a constant depending on the circuit parameter, no? These are fixed, no? These are constants depending on the circuit parameter. Unlike when we're working in the time domain, pag minsan meron tayong differentiation, pag minsan meron tayong integration. Naalala nyo yung equations natin for your inductance and your capacitance, there's either differentiation, no? V is equal to L di dt, no? Or I is equal to C dV dt, no? That's for the capacitance, or there's integration, no? V of L is equal to 1 over L the integral of I dt, no? Pero dito, laging constant yung mga ratios natin. Okay? So that's what I'm saying here, no? The relationship between voltage and current for all circuit elements is algebraic, no differentiation or integration. So pwede tayong mag-apply ng quote-unquote Ohm's law. And our Ohm's law, our modified Ohm's law is V is equal to ZI. Imbis na V is equal to RI, no? V is equal to Z times I. Yan yung Ohm's law natin, no? And you're going to find out that all methods of circuit analysis developed for resistive circuits can be applied now to your transform network. So the best way for me to illustrate this is through an example. So let's take an example. So this is a very simple circuit. I have a sinusoidal voltage source whose voltage is 100 cosine 10t. So walang phase angle. The phase angle is equal to 0. Meaning to say, since this is cosine, at time t equal to 0, your cosine function is at its maximum value. Dahil cosine siya. And the problem here is to find the current that flows, okay, that flows through my circuit and the voltage across my inductance. Now, these are both going to be sinusoidal quantities. Kung sinusoidal yung excitation natin, no, if our sources are sinusoidal, our circuit responses will also be sinusoidal. That's a characteristic of linear circuits. A linear circuit, your response will always be of the same form as your excitation. So kung at steady state that is, ano? So kung DC ang excitation, DC din yung magiging response. Kung sinusoidal yung excitation, sinusoidal din yung magiging response. Okay, so how do I solve for the time domain expression, no? The expression in terms of T of Is of T and V's of L. So the first step is to transform the network. Okay. how do I transform my network? No? My V's of t, which is equal to 100 cosine 10t, I will transform into a phasor. Joseph, can you tell me what the phasor equivalent is of V's of t? We're using the modified transformation. No? Ano yung phasor equivalent ng V's of t? Joseph? Are you there? Wala yata si Joseph. What about Albert? Albert?
Sir, is it 5 square root of 2 and wala na pong angle?
Ano?
5 square root of 2, then wala na pong angle. Angle of 0.
Angle of 0, no?
0.
Yeah, it's not, well, yeah, it's 100 over the square root of 2, no? 100 over the
50 square root of 2.
50 square root of 2. Okay. Okay. So yeah, teka, let me I just want to be wala na yung kasama mo, no? Okay. So ito, okay, V is going to be 100. Let me just put it this way first, no? At an angle 0 degrees, no? Pero tama yung sagot mo, no? Or 50 times the square root of 2 at an angle of 0 degrees. Okay? Ngayon, yung 8 ohms, okay? Yung Z's of R, no? Is going to be equal to 8 ohms also. Kasi yung resistance will just transform into a resistance. Okay? Now what about Z's of L, no? Z's of L is equal to J omega L. No? Now, what is J? Well, J, square root of -1. No? What is omega? Ang omega natin is equal to 10. No? So this is my omega. Omega is equal to 10. And then L is 0.6. Okay? So Z's of L is J6. And the units of this is ohms. By the way, the units for impedance is always ohms. So ang units nito is ohms because it is a ratio of voltage to current. No? So my transformed circuit, okay, is going to look like this. No? This is going to be my transformed circuit. This is my voltage source. Okay? This is my Z's of L, no? This is my Z's of L, and then this is my Z's of R. So ito, this is our time domain circuit. This is the phasor domain circuit or the frequency domain circuit. So the next step is to solve for the required circuit quantities in the frequency domain. Now, what can I do? I can apply, excuse me, no? I can apply KVL to this loop. No? So applying KVL, okay, V is equal to V's of R plus V's of L. No? Okay, sa transform circuit ko ngayon, the voltage across my resistor will also be a phasor. The voltage across my inductance will also be a phasor. And my current will be a phasor. So V is equal to V's of R plus V's of L. Of course, susundan natin yung polarity, no? This is a voltage rise. This is a voltage drop. This is a voltage drop. No? So KVL, okay, the sum of the voltage rises is equal to the sum of the voltage drops. Ano ngayon yung V's of R? No? V's of R is just I multiplied by Z's of R. Okay, so this is I multiplied by 8. No? And V's of L is just I multiplied by Z's of L. No? So this is I multiplied by J6. So ano ngayon tong V? This is simply now I multiplied by 8 plus J6. So I can solve for I. No? So from this, I can solve for I. I is now going to be V over 8 plus J6. No? So this is 100 over the square root of 2 at an angle 0 degrees over 8 plus J6. Na-practice mo na bang gumamit ng complex function sa calculator? Na-practice na ba ninyo gumamit ng complex function sa calculator? Either of you?
Nakapag-try na po before ata.
Okay. So ito, actually pindot lang to sa calculator, ano? So dapat mag-practice kayo niyan. Okay? But if you click that in your calculators, so I'll just give you the answer. This is going to be, okay, sorry. This is going to be 5 times the square root of 2 at an angle minus 36.87 degrees amperes. Okay. Now this is already the effective value of I. No? So 5 times the square root of 2, which is equal to, I don't have that, no? 5 times, yeah, this is 7.07 amperes. This is the RMS. This is already I, no? This is already I, RMS. That's already the effective value of I. So pag minsan, yun lang yung tinatanong, no? Pag tinatanong lang, ano yung magiging RMS value nitong current na to, actually dito pa lang alam na natin yung sagot. Okay, so this is the Phasor value of I. What is V of L? The Phasor value of V of L, that is just I multiplied by J6. Again, you just do that in your calculator. No? This is 30 times the square root of 2. And this will be at an angle 53.13 degrees. And this is volts. So any question? So I have computed for the Phasor value of I and the Phasor value of V of L. Okay, what is the next step? No? Since ang hinihingi ng problem is I of t and V of t, the next step is we have to perform the reverse transformation. We transform the calculated quantities back to the time domain, and we do this if it is required. No? So ang I natin, okay, if you recall I, this is 5 times the square root of 2 at an angle minus 36.87 degrees. So doing the reverse transformation, I of t, okay, is 5 times the square root of 2 times the square root of 2. No? Square root of 2 multiplied by 5 times the square root of 2. Okay, cosine. Omega is equal to 10t, okay, minus 36.87 degrees. No? So this is just going to be 10 cosine 10t minus 36.87 degrees. So yun na yung value nung I of t natin. Okay, this is the value of I of t. Okay. Similarly, V of L, okay, is 30 times the square root of 2 at an angle of 53.13 degrees. So V of L of t is just going to be 30 times the square root of 2 times the square root of 2. So this is going to be 60 cosine 10t plus 53.13 degrees volts. No? Don't forget the amperes. No? This is amperes and this is volts. Okay? Any questions? Maybe Joseph, you can just review, no? Na disconnect ka, but maybe you can just review later on yung ginawa natin, no? Any questions? So andali, ano? It's quite easy. Okay? If we had tried solving the problem in the time domain, okay, let me just illustrate that, no? For the sake of illustrating it. If I had tried to solve it in the time domain, so I would have had the expression, ano? V's of t is equal to V's of R of t, okay, plus V's of L of t, no? Now V's of R of t is I's of t multiplied by R, no? And V's of L of t, okay, in terms of I, no, is equal to L di of t by dt. Okay, so this is going to be my expression which I have to solve, no? Ano nga ba yung ano? Sorry. 100 cosine 10t. So this is 100 cosine 10t, no? So based on this, you have to solve for I in the time domain. So kailangan marunong kayo mag-solve nitong mga equations na ganito, no? In the time domain. You call this a differential equation. So it's not easy to solve differential equations. Ito madali-dali pa to, no? Mathematically. But when you have more complicated circuits, it gets more complicated. If we do it in the Phasor domain, we did it very easily. Okay, so just some things that I wanted to point out, no? Freeze your screen, sorry. Here, no? So this is consistent with an inductor, no? In an inductor, okay, this is my current. My current here is at an angle minus 36.87 degrees. That's the current through the inductor. The voltage across the inductor, the angle is 53.13 degrees. If you get the difference in angle between voltage and current, that is 90 degrees. No? And that's consistent with an inductor. An inductor, the current lags the voltage by 90 degrees. Now these expressions, I's of t, no? I's of t equal to 10 cosine 10t minus 36.87 degrees, ito 60 cosine 10t at an angle 53.13 degrees. These expressions are steady state expressions for the circuit current and inductor voltage respectively. We cannot use the Phasor method to determine the transient response kasi kapag itong circuit na to binuo natin, no, hindi agad-agad lalabas tong mga currents at saka voltages na to, no? Magkakaroon muna ng parang transient where the currents and voltages will build up, and then after some time ito na yung magiging steady state, no? So yung transient response hindi natin kukunin sa 1 2 3 sa triple E 1 2 3. Kukunin niyo yan sa triple E 1 3 3 if I'm not mistaken, no? If I'm not mistaken. Okay? Okay, ang kagandahan sa frequency domain analysis, okay? The beauty of frequency domain analysis is we can actually use all methods of analysis developed for resistive circuits. So anong pwede natin gawin sa frequency domain analysis? Pwede tayong mag-network simplification. Pwede tayong mag-simplify ng impedances in series, impedances in parallel. Pwede tayong mag-Y to delta at saka delta to Y conversion. We can do voltage divider and current divider. We can do that. We can do source conversion. We can do node and mesh analysis. We can use the principle of superposition because it's a linear network. And we can also use Thevenin's and Norton's equivalent circuit. So lahat nito magagamit natin. So for example, impedances in series, if I have n impedances in series, and alam na ninyo no anong ibig sabihin ng in series, then my equivalent impedance, if I were to simplify this into a single impedance, will just be the sum of all the individual impedances. Meaning to say, no, if this is the voltage across all my impedances, this is the current through all my impedances, no, the ratio of my voltage to current, which is A equivalent, will just be equal to all of this. And that's very easy to show. Pag impedances in parallel, so ito yung impedances naman in parallel, no? You have two impedances are in parallel if they are connected at both their ends. So dapat connected sila both at this end at the other end. So here you have n impedances in parallel. If I wanted to convert this to an equivalent impedance, okay, ito yung magiging formula natin. Again, this is very easy to show. No? Okay. The equivalent impedance is the reciprocal of the sum of reciprocals of the different impedances. No? Note that these are actually the admittances. No? Or rather, yeah, the admittances. No? This is actually Y1, this is Y2, all the way to Yn. So the equivalent impedance is the reciprocal of the sum of all admittances. And when you have a special case, two impedances, ganun din, no? Yung formula is just product over the sum. So pag two impedances, Z1 at saka Z2, ang Z equivalent is Z1, Z2 over Z1 plus Z2. And then yung delta to Y and Y to delta. So if I have, okay, this is now equivalence with respect to 3 points, no? 1, 2, 3, no? And that's this, and this point, no? If I have a delta, I can convert it to an equivalent Y, or if I have a Y, I can convert it to an equivalent delta. And then if I have delta to Y, so again, very similar to your resistive networks, I have a common denominator, Z's of D. Okay. Z's of A would be Z1 multiplied by Z2. Okay, yung nasa kaliwa nitong Z's of A, nasa kanan ng Z's of A, Z1 at saka Z2, divided by my denominator. So Z's of B, ganun din, ano? Z2, Z3 divided by my denominator. And Z's of C, Z3, Z1 divided by my denominator. Yun yung delta to Y, no? Tapos yung Y to delta, my numerator is ZA, ZB, ZB, ZC, ZC, ZA, the sum of those three. And then Z1 is Zn. So pag natin Z1 is my numerator divided by yung nandito sa opposite leg, no? Divided by ZB. Z3 is my numerator divided by the opposite leg. So that's ito, no? ZA, and Z2, ang opposite leg niya is ZC. So ito yan. So yun yung circuit simplification. So, and this is just a word of caution, when simplifying a circuit, make sure you do not eliminate any circuit quantity that you want to determine. So ganun din with resistive circuits. So for example, if I have two impedances, Z1, Z2, and ang problem ko is I need to get B's of Z2, no? B's of Z2. hindi ko pwedeng i-simplify ito. No? So if I need to determine this of Z2, I cannot combine Z1 and Z2. Kasi pag pinag-combine ko itong dalawang to, syempre mawawala na itong variable na to. Mawawala na yung vis of Z2 ko because nawala na itong Z2 kasi pinag-isa ko na yung Z1 at saka Z2. So that's an important rule in circuit simplification. If you have when in your simplification, you have to make sure you do not eliminate the circuit quantity you want to determine. Okay, so let's do this exercise. Transform the circuit to its frequency domain equivalent and solve for the equivalent impedance with respect to terminals A and B. Assume omega is equal to 377 radians per second. So alam natin 377 radians per second is 60 hertz. Okay. So let's first convert this to its frequency domain equivalent, no? or phasor domain equivalent. No? Okay, itong 25 ohms will stay 25 ohms, right? Because Z of R is equal to R. Okay, what is going to be the impedance of this branch? Okay. Yung Z's of C, no? So let's call this let's say this is my capacitor Z, this is my inductance L. Z's of C is equal to minus J over omega C. So this is minus J over 377 multiplied by 10 times 10 to the minus 3 because this is 10 millifarads. Okay. Let's see if I have the answer to that. No. Dali lang. Okay. If I compute for this, no? If I compute for this, J of C is equal to minus J 0.27 ohms. So ang impedance na to of this branch, this is going to be 20 minus J 0.27 ohms. No? Let me call this, let me call that Jx. No? Let me just call that J of X. Okay. Let me call this R1. So this is J of R1. No? Then if I call this R2, this is now J of R2. Okay. Now what about J of L? J of L is equal to J omega L. This is by formula, no? So this is J 377. Ang L natin is 20 millihenries, no? So this is 20 times 10 to the minus 3. Okay. If I compute that, I'm going to get, this is J 7.54 ohms. Okay. Now, what is the parallel combination of these two? Let me call this J of Y. No? J of Y, this is JR2 in parallel with J of L. No? By the way, yung J of L natin is J 7.54 ohms. Okay. So using your formula product over the sum, no? Because you have two impedances in parallel, this is going to be equal to 55 multiplied by J 7.54 over 55 plus J 7.54. So pag nagpindot-pindot ka sa calculator mo, practicein nyo yan, ano? Feeding this into your calculator, you're going to get J of Y is going to be 7.47 at an angle 82.19 degrees. Remember, these are not phasors, huh? These are not phasors. These are just complex numbers. Your impedances are not phasors. It's only your voltages and currents which are phasors. Okay, Albert, anong sunod na pwedeng simplification na magagawa natin?
In series po yung impedance, yung Z of X and Z of Y.
That's right, no? So Z's of X and Z's of Y are now in series, ano? So I'm going to have my 25 ohms here. Tapos dito meron akong Z's of X. Dito meron akong Z's of Y. Okay, so Z's of X plus Z's of Y is just now going to be ano nga ba ito? 20 minus J 0.27. Okay. Plus 7.47 at an angle 82.19 degrees, no? Plus 7.47 at an angle 82.19 degrees, no? Actually, if I were to do this manually, I would have to convert this to rectangular form. But ang kagandahan ng mga calculator, you can just enter this, no? Pwede mo ipasok to diretso, no? If you were doing this manually, kung wala kang complex calculator, you have to convert this first to rectangular form and then add the real components together, then add the imaginary components together. But anyway, that's Z's of X plus Z's of Y. Let's call this Z's of Z, no? Z's of Z. Do I have the answer to that? Let me just solve it. Huh? This is going to be equal to 22.19 at an angle 18.74 degrees ohms. So finally, ZAB will be 25 ohms in parallel with 22.19 at an angle 18.74 ohms. No? And here I have the answer to this. Okay, this is going to give me 11.915 at an angle 9.94 degrees ohms. No? Or if you convert this to rectangular form, this is 11.74 plus J 2.06 ohms. So ito yung final answer natin. Okay. Is there any question? Any question? So ang ano lang dito, no? You just have to get used to your calculator and of course be very careful in transforming from your circuit elements to your impedances. Okay, here's another exercise. No? Given V's of t equal to 100 cosine 10t, determine V's of L using voltage division. Okay? Determine V's of L using voltage division. Okay, so the first step is to transform. No? So step 1, you transform the network. Okay, so ano magiging source natin? No? Our source is going to be 100 over the square root of 2 at an angle 0 degrees. No? And then this is going to be 8 ohms. Okay. Okay, omega is equal to 10. So ito, omega to. So pareho to, no? So this is J6. This is J6 ohms. Ito ngayon yung V's of L. Okay, ano yung voltage divider formula natin, no? Remember, this is V, no? This is V. V's of L is equal to V multiplied by J6 all over 8 plus J6. Yun yung voltage divider natin. Okay? So this is your voltage divider. Okay, and if I do this, no, yung V is 100 over the square root of 2 at an angle 0 degrees. And then this is J6 over 8 plus J6. I'm just going to get 30 over the square root of 2 at an angle 53.18 degrees. This is going to be in volts. Therefore, V's of L of T is now going to be 60 cosine 10t plus 53.13 degrees volts. So this is exactly the same earlier, pero ang ginamit nating principle ngayon is voltage division. May tanong, Albert? Is it okay?
Yes po.
Okay. Sige. Another example, no? Given ito, V's of T, 200 cosine 10t, find I1, I2, and I3. Find I1, I2, and I3. Okay, so the first step is transform the network. Okay. So again, V is just going to be 200 over the square root of 2 at an angle 0 degrees. Let's call this Z1. Ito, tawagan natin itong Z1. Okay. Z1 is just going to be 6 plus J, 12. No? Kasi ito yung omega. This is omega. So omega L is going to be equal to 12. So Z1 is 6 plus J, 12. No? Okay. Ito, let me call this Z2. Ito naman, Z2. Z2 is going to be 5 plus J5. No? Again, omega L is 10 times 0.5, which is 5. Ano? And then ito, sabihin natin, this is Z3. This is Z3. So the Z3, which is just Z's of C, this is minus J over omega C. This is just going to be minus J10. That's 10 times 0.01. 10 times 0.01 reciprocal, no? That's going to be minus 10. And then minus J, no? So it's going to be minus J10. Okay. So my transform network okay, I'm going to have a source here. This is 220 over the square root of 2 at an angle 0 degrees. Okay, drawing ko na lang ganito. This is 6 plus J12. This is 5 plus J5. These are in ohms, no? Ohms. And this is minus J10. Okay. So, ang current dito ngayon will be the phasor I1. The current here will be the phasor I2. And the current here will be the phasor I3. Okay, so ang problem ko is I want to get the time domain expression for I1, I2, I3. So, isosolve ko muna yung phasor expressions. By the way, this is I1, I2. No? So, solve ko muna yung phasor expression and then you convert ko later back to the time domain. No? Now, madaming techniques yan. There are many techniques that we can apply. No? So, we can use nodal analysis. I can do network simplification. I can do source conversion. In fact, those are only 3 of the possible techniques you can use. Ano? So, let's just do one. Ano? For this afternoon, let's just do one. Sabihin natin gamitan natin ng nodal analysis. Okay. So let me redraw again my circuit. So this is 200 over the square root of 2 at an angle 0 degrees. Okay. So this is J1, J2, J3. Okay. So ito yung I1 ko, I1. Ito yung I2. This is my I3. Let me make this my reference and let me define this as my node, no? To which I will apply KCL. So let's say I assign the node voltage V of X to this particular node. Okay, Albert, can you tell me what the nodal equation is going to be? Para ma-practice ka. Ano magiging nodal equation if I apply KCL here?
Yung pong I sub 2 plus I sub 3 minus I sub 1 equals 0.
Yes, that's right. Ano? But in terms of V of X, yung ginagawa natin sa nodal
Yes,
analysis.
V of X over I of 2.
No. It should be over an impedance. No?
Over Z of 2 po. Z
Yeah,
of 2.
Z2. Okay.
Plus V of X over Z of 3
Okay.
minus V of X minus 200 over square root of 2 at an angle of 0.
Sigurado ka
Over.
minus? Sigurado ka minus or plus? No? Ingat ka, no? It should be plus, no? Plus V of X minus 200 over square root of 2 at an angle 0 over Z1. Nakita mo bakit plus?
Apo.
Kalimutan mo muna yung ano, no? Kalimutan mo
Apo.
muna yung I1, I2, I3. Di ba? Basta applyin mo lang yung KCL dito. Okay. So yung current dito papunta sa kaliwa is V of X minus 200 over the square root of that an angle 0 over J1. Nakita mo?
Yes po, yes po.
Nakita mo or kailangan mo pa ng time to see it?
Okay na po, okay na po.
Okay. So this is now equal to 0, no? In other words, when you're doing nodal analysis, kalimutan mo muna itong mga directions of currents na to, no? Basta gamitin mo yung alam mo for nodal analysis, no? Kasi mamaya, we will be able to compute for I1 knowing V of X, no? The value of I1 is going to be 200 over the square root of 2 minus V of X over Z1. So if you wanted to make this minus, dapat baliktad tong dalawang to. Di ba? Okay. So anyway, so this is your nodal equation. No? So this is my nodal equation. Okay, so this is now I can simplify this now. No, this is v of x multiplied by 1 over z2 plus 1 over z3 plus 1 over z1, no, is equal to v, no, or 200 over the square root of 2 at an angle 0 degrees over z1. So computing for v of x, okay, so this is 200 over the square root of 2 at an angle 0 degrees over z1. Ang z1 ko is 6 plus j12. This is 1 over z2, 5 plus j5, plus 1 over z3 minus j10, plus 1 over z1, which is 6 plus j12. No? So notice again, this is just practicing with your calculator. No? So pag nag-practice ka with your calculator, subukan mo na lang sa sarili mo, no? You're going to get v of x is 50 times the square root of 2 at an angle minus 36.87 degrees volts. Okay, so mako-compute ko ngayon for I1. I1 is equal to v minus v of x over z1. No? So this is 200 over the square root of 2 minus 50 minus 36.87 degrees all over z1, which is 6 plus j12. No? Okay, again, this is just a calculator problem now. This is going to be 7.071 at an angle minus 36.87 degrees amperes. Teka, sandali ah. Anyway, okay. So ito yung I1. No? Similarly, I2 is just v of x over z2. No? And this is 10 at an angle minus 81.87 degrees amperes. And I3 is just v of x over z3 at an angle 53.13 degrees amperes. So alam na natin to. So madali na natin makukuha yung I1 of t. No? So I1 of t, my amplitude will be 7.071 times the square root of 2. That's equal to 10 cosine omega t. Yung omega natin is equal to 10. Ano? Cosine 10t minus 36.87 degrees. This is amperes. I2, you multiply this by the square root of 2. Itong 10, multiply natin by the square root of 2. So that's 14.14 cosine 10t minus 81.87 degrees. And finally, I3 is going to be but this one multiplied by the square root of 2, so that's going to be 10 again, cosine 10t plus 53.13 degrees, 53.13 degrees. Okay. So that's doing nodal analysis, no? We could have done network simplification, no? Very quickly, ano? Ito yung circuit natin. J1, J2, J3. We could have simplified this, no? Na isang J equivalent lang. Where J equivalent is J1 plus J2 in parallel with J3. Pag nakuha ko na yung J equivalent, masosolve ko na for I1. No? Kasi ito yung I1. My I1 is just V over J equivalent. So ito masosolve ko na. Kung alam ko yung I1, paano ko masosolve yung I2? Albert, may idea ka?
Current division po.
That's right, no? So I2 and I3 can be solved using current division. Okay? So I2, for example, will just be I1, okay, J3 over J2 plus J3, no? And I3 will be I1 J2 over J2 plus J3. Okay? So that's how you do it using network simplification, no? And you can do it using source conversion, no? Pwede ring source conversion. Kasi pag source conversion, anong pwede nating convert to a current source, no? Yung V at saka J1, V and J1 can be converted to a current source. Di ba? So ang mangyayari, ito current source ngayon yan, this is going to be V over J1. And then meron tayong tatlong impedances in parallel, no? This is going to be J1, J2 at saka J3. So pag alam na natin pag ginawa natin to, makukuha na natin yung I2. So this is I2 at saka I3 using current division. Can be solved using current division. Pero ang current division natin ngayon, hindi natin pwedeng gamitin yung shortcut formula, no? Hindi pwedeng itong mga formula na to kasi tatlo na to, no? So you have to use the long current division formula. And then when you know I2 and I3, it's easy to get I1. I1 is just I2 plus I3. Okay, so what I encourage you to do is subukan mo na lang, no? And dapat yung sagot mo in all the methods should be consistent. Anyway, alam na natin yung mga sagot dito, no? This one and this one. So for practice, you try solution 2, then you try solution 3, and the answer should be consistent, no? I'm going to provide you these slides because there's another exercise here, no? And in this exercise, ang gusto kong i-point out is, again, we can use nodal analysis, we can use superposition, and I also wanted to give you an example using Thevenin's theorem, so you can also try those exercises on your own, no? Maybe, and that's what I'll take up with you, no? Itong exercise na to on Thursday. So I'll stop first here. May tanong ba? Do you have any question?
Wala naman po.
Okay. Medyo kailangan i-digest, ano? So papadala ko na lang yung notes, tapos tignan mo rin of course yung official material kasi this is just supplementary. Again, I always point it out, this is just supplementary. Tapos i-digest mo na lang. Okay? So that's all I have for today. If you don't have any questions, then I'm going to end the session.
Thank you po.
Okay.